Welcome to the last video of Chapter 5, which covers vertical motion. Vertical motion is going to put together most of what we've done this chapter. You're going to set up an equation and then you're going to solve to find various aspects of things that go along with that equation. So the vertical motion equation at the top is going to be h equals negative 16t squared plus v sub 0 t plus h sub 0. So first thing that we should probably do is define what all these variables mean. H sub 0 is your initial height. V sub 0 is your initial velocity. And h is the height after a certain amount of time. So these problems are going to deal with either something being shot or something falling or something diving, and we're looking at after so many seconds, what height am I at? When am I going to be at the highest height? When am I going to hit the ground? Things like that. So if we look at the first example, it says an object is fired straight up from the top of a 150-foot tower at a velocity of 75 feet per second. So if we think about this, we're at the top of a tower, we shoot off this object, it's going to rise for a while, but then eventually it's going to start coming back down again. So it's going to be an upside down parabola. So for part A, we're going to have to write our vertical motion equation. So we're going to get h equals negative 16t squared plus, it says we have a velocity of 75, so plus 75t plus, and then we are at a 150-foot tower. So t is always going to be time, which in this case is in seconds, and then h is going to be your height after a certain amount of seconds. So for example, in B, I could ask you to predict the height after 3 seconds. So what you're going to do is you're going to plug in 3. So we have negative 16 times 3 squared plus 75 times 3, add 150. So you're going to be allowed a calculator for questions like this. So when you put this in your calculator, you get the height after 3 seconds to be 231 feet. So after 3 seconds, whatever this object is at 231 feet. So now moving on to C. At what time or times will the object be 235 feet off the ground? And then it asks us why there are 2 positive answers. So to find both of those answers, we want to know at what time, so that tells me that I'm looking for t. Is the object going to be 235 feet, so that's a height, off of the ground. So using our equation, we get 235 equals negative 16 t squared, add 75 t, add 150. Okay, so this is a quadratic equation. This is what we spent weeks now learning how to solve. So we have the factoring method, we have the square root method, we have completing the square. So now with all these numbers though, I'm not going to try to factor. You can, but I don't think that's going to end up well for us. We can try to complete the square, but I think honestly our best option is to do the quadratic formula. So we're going to subtract 235. When we do that, we get 0 equals negative 16 t squared, add 75 t minus 85. Now remember, you can only do the quadratic formula when your equation is set equal to 0, which is why we had to subtract the 235. Now in this case, our A is negative 16, our B is 75, and our C is negative 85. So we have the opposite of B, so negative 75 plus or minus the square root of B squared, so 75 squared, minus 4, our A is negative 16, and then our C is negative 85, and this is all over 2A, so all over 2 times negative 16. Okay, so now at this point, like I said, you're going to want to put that in your calculator, so I'm going to erase all this to give myself a little bit more room. So take out your calculator and punch this in and see what you get, please. If I start with the stuff underneath the square root, I get negative 75 plus or minus the square root of 185 all over negative 32. Okay, so now in this case, there's two answers. There's the negative 75 plus and the negative 75 minus. So first you're going to do negative 75 plus the square root of 185, and then you're going to divide that by negative 32. When you do that, you get 1 time to be 1.919 about, and then you're going to do negative 75 minus the square root of 185 divided by negative 32. And when you do that, you get the second time to be 2.769 seconds. Okay, so now the question is, why are there two answers? Well, if we think about our object, if we're currently at 150 feet and the object is shot straight up, it's going to hit 235 feet on its way up and then also on its way back down again. So that's why we get two positive answers. So now if we move on to D and E. So D says, what is the maximum height the object reaches? How long does it take for the object to reach its maximum height? Okay, so if we're talking about maximum height, if you remember from a quadratic, the maximum and the minimum always happens at the vertex. So whatever our maximum height is going to be at the vertex. So if we write our equation again, we get negative 16t squared plus 75t add 150. Now if you remember way back from the beginning of the chapter, the way to find the x-coordinate of the vertex is negative b over 2a. So in this case, negative 75 over 2 times negative 16. When I divide that, I get x to be 2.34375. Now, that can't be the maximum height. If we think about our x and our y here, or really t and h, x is time. So the maximum height is reached at 2.34375 seconds. To find what that height actually is, I'm going to have to take my x value and I'm going to have to plug it in to my equation. Sorry, almost drew it to the wrong spot. So it's going to go into this equation. So if you want to take a minute right now and try to put it in the calculator with me, I'm going to do negative 16 times 2.34375 squared plus 75 times 2.34375, add 150. So when I do that, I get my maximum height to be 237.89 feet, about. I'm rounding that. So after 2.34 seconds, our object reaches a maximum height of 237.89 feet. And what I would like you to do is circle really big the fact that you're finding the vertex. So again, this goes back to something you learned at the very beginning of the chapter, that the vertex is always going to be the maximum or the minimum. So then our very last question that we can ask is, how long does it take for the object to fall back to the ground? So if it falls back to the ground, that means that the height it's at is 0. So if we set our equation equal to 0, we're looking for the solutions or the roots or the zeros. They all mean the same thing. So again, we talked about this before. We have the square root method, completing the square, factoring. You can solve this however you would like. Again, my suggestion would be that you do the quadratic formula. So our a is negative 16, our b is 75, and our c is 150. So we're not going to get the same answers, though, that we got in part C, because part C we were looking for 235 feet off the ground, not ground level, so not h equals 0. So again, if we do the quadratic formula, we get opposite of b, so negative 75, plus or minus the square root of b squared minus 4 times a times c, all over 2a. So then what I would do if I were you is I would put the numbers underneath the square root in first and figure out what that is. When I did that, I got 15,225 to be underneath the square root. And then remember, the quadratic formula is always going to give you two answers, the negative 75 plus and the negative 75 minus. So if I do the addition first, I get negative 1.512. And then I do it again, except this time I do negative 75 minus, and I divide it by negative 32. And this time I get about 6.2 seconds. Okay, now negative answer doesn't make sense. We're talking time here. So after 6.2 seconds, we say the object has fallen back to the ground. So as you can see, this is a lot of what we've done before. You're going to be doing some quadratic formula, you're going to be looking for the vertex, and then you're going to be writing an equation. Now, it's all based on how you do on this equation. If your equation is wrong, you're going to get all the answers wrong. So for the rest of the video, I have a problem that I would like you to try. If you would flip the page, please. Okay, so I want to make sure that we set this equation up correctly. So this one says, during World War I, mortars were fired from 3 feet below ground. The mortars had a velocity of 150 feet per second. So we're going to start by writing the vertical motion equation. So it's going to be h equals negative 16t squared plus, our initial velocity is 150. And then here's the part that's tricky, is it said that these mortars were fired from 3 feet below ground. So below ground means our initial height is negative 3. So this is the equation that you're going to do. I'm asking you similar questions to the previous page. So what I would like you to do right now is I want you to pause the video, and I would like you to try the rest of them on your own. This is probably going to take you about 5 or 6 minutes, so please dedicate the next 5 or 6 minutes to trying the rest of these problems. When you come back, I will give you the answer. Good luck! Okay, so hopefully you tried these on your own. I'm not going to be showing you any work. So if you come in tomorrow with all these answers written and no work, you will not be receiving credit. For part B, you should have gotten the height to be 1,831 feet. So you should have gotten this by plugging your 7 back into the original equation. For part C, you should have gotten 2 times. You should have gotten 2.945. And then also 6.43 seconds. Again, if you're confused on these, please make sure you go back to the previous page and also write down so that you know to ask your teacher tomorrow. For part D, you should have gotten the maximum height to be 348.5625 feet. So that's the y value of the vertex, after your x value is 4.688 seconds. And then for part E, you should have gotten that the mortar falls back to the ground after 9.355 seconds. Hopefully that went well for you. If not, please make sure that you go back and try to rework through some of these. Make sure if you have any questions, you write down so that you can ask your teacher tomorrow. Now, to end the video, what I want to do is I want to show you how to find some of these answers on the calculator. So for A and B, those should have been pretty easy, but for C, D, and E, there's a way to do this on the calculator. So if you would get out your calculator right now, it's probably out already, I would like to show you how to do this. Let's start by looking back at C. So C was the one that asked you at what time were the mortars 300 feet off the ground. So what you should have done in this case is you should have set 300 equal to your h. So 300 equals negative 16t squared plus 75t minus 3. And then in order to use the quadratic formula, you had to subtract 300. So you got 0 equals negative 16t squared plus 75t minus 303. And then you did the quadratic formula. Now, that definitely works. Some people, though, I know don't really like the quadratic formula. So if you're one of the ones who doesn't like to use the quadratic formula, the calculator can be very helpful. Okay, so what you're going to do in this case, once you have everything set equal to 0, you're going to take out your calculator, and you're going to go to y equals. So I'm going to clear out what I have there, and I need to put in my equation. So I'm going to put in my negative 16t squared, but there's no t button, so use x, plus 75x minus 303. Now, we want to know when this is equal to 0, So what you're going to do is you're going to put 0 in your other equation. From here, you're going to want to hit zoom 6, so the normal zoom. So here's our quadratic. Now let's look at one thing. First of all, the quadratic is facing downwards, which makes sense. The mortar is going to go up into the air and then eventually come back down. So what I want to do is I want to find the zeros. I want to find when it crosses the x-axis. So to do that, I'm going to hit second calc, and I want to calculate the point of intersection between my two equations. So if you hit enter 3 times, you get the first point to be 2.95, like we found using the quadratic formula. Now, that's only the first time that our equation is equal to 0. If you'll notice, there's also that 0 to the right. So we're going to have to do the same thing, go back to second calc, calculate the point of intersection again. So this time scroll all the way to the right, so you're going to have to keep hitting right until you see your point near that other 0. So there, I found it, and again I'm going to hit enter 3 times until I find my other point of intersection. So the other time that the mortar is 300 feet off the ground is at 6.43 seconds. So these are the same 2 answers that you found using the quadratic formula. If you prefer to use the calculator, you are welcome to. I prefer the quadratic formula because it will always work. But if you like the calculator, you are more than welcome to use it. So now on to part D. So part D is the one that asks us for the maximum height. So remember we talked about in the previous problem that anytime we're talking about maximum or minimum, we're really just looking for the vertex. So this is something that you guys did at the beginning of the chapter. Okay, so what you're going to want to do for this one this time is, hopefully you remember this, you're going to want to go back to y equals, and you want your original equation in there, so the one we wrote in part A. So the equation I currently have in here says minus 303 at the end, so I just need that to be minus 3. And now what we need to do is we need to calculate the vertex, or the maximum. So normally I would have you do zoom 6, which is the standard zoom, but because these mortars reach such high heights, we're not going to be able to see the maximum. So anytime you're looking for the maximum or the minimum, try zoom 0. So when I do zoom 0, I do in fact see the maximum. So if you remember from before, you're going to hit second calc, and you're calculating the maximum. Now way back from the beginning of the chapter, if you see at the bottom of the screen, this is where you have to find the left boundary and the right boundary. So what you're going to do is you're going to move your cursor to the left of the maximum and hit enter. And my cursor is already there. Then you're going to have to move to the right of the maximum. So hit right until you're clearly to the right of the maximum. And then once you've done that, you can hit enter again. And then you're going to need to hit enter one more time. So now you can see that we hit a maximum height of 348.5625 after 4.69 seconds about. So this shouldn't be anything new. You did this at the beginning of the chapter, calculating the maximum and the minimum. You just need to remember that the maximum happens at the vertex. So then the last one that I need to show you on the calculator is how to do part E. Okay, so to do part E on the calculator, it's very similar to part C. So in order to find the time when the mortar falls back to the ground, when it falls back to the ground, that means that its height is 0. So you took your original equation and you set the height equal to 0. So now we're back to a similar spot where we were in C. So what you're going to do is you're going to go to y equals and put your equation in. So my equation was already in there. And then what you want to make sure you do, I don't know if you saw that I did it, is you want to have y equals 0. So we're looking for when our equation is equal to 0. So then, as you saw, I did zoom 6. And I can see I have a 0 all the way out to the right. So I'm going to go to second calculate, and I want to calculate the point of intersection. So when my equation is equal to 0. Now you see I found the wrong intersection point. So I'm really interested in this point over here, not the one on the left, but I found the wrong point. So what I'm going to have to do is I'm going to have to go back and calculate the point of intersection on the right. So again, it's the point of intersection because we have y equals 0 in our other equation. So we have both equations entered into the calculator. So what we're going to do is we're again going to go back to second calculate and calculate the point of intersection again. But this time we need to get close to that point. So like we did before, you're going to have to push your cursor all the way to the right until you see it on the right-hand side, so that the calculator knows which point we're looking for. So it looks like I'm close. If I hit enter 3 times, I see that the point I'm actually looking for is 9.355 seconds. So again, there's 2 methods that I showed you, algebraically and then using the calculator. Algebraically, you're either doing the quadratic formula or you're solving for the vertex. On the calculator, when you're doing the quadratic formula, the same way to do that is to find the point of intersection. And then finding the vertex is really finding the maximum. So it's up to you, whichever method you feel more comfortable with. Your teacher can help you in class tomorrow if you're having trouble with either one. Please make sure that you come prepared with any questions that you have. See you tomorrow.